Okay, welcome again to the retronetcall tonight about Teletex, somewhere between Telex and Telefax. That really summarizes the talk, and we can all go home now. So I wanted to share the state of my research into Teletex as a disclaimer. I never used Teletex back in the day. I only discovered it a few years ago while reading about retro computing, retro networking topics, and found it rather fascinating and rather exotic. It has always been a niche system, even in its prime day. We will see the number of subscribers was very small comparatively to other services and other networks. All the information I present is based on historical books, specs, articles, manuals, you name it. There might be things incorrect. Please let me know if you have any better knowledge or ideas or pointers. So, what is Teletex? It's a service to exchange formatted pages of text over telecommunications network. You can think of interconnected electronic typewriters. So you enter some text at one end and it comes out at the other end. Now, many people will say, well, that sounds just like Telex or Fernschreiber in German. Yes and no. Telex doesn't preserve formatting on a page, and it only has 5-bit characters. So you cannot really have lots of special characters or graphical characters or whatnot. So Teletex implements an 8-bit character set with escaping. So there's a total, I think, of 390 symbols that you can represent in the Teletex scheme, using those escape characters to get more than the 256 characters possible in the 8-bit character set it has. So it's more than Telex in that sense. It's less than Telefax, where Telefax is the transmission of pixels. Teletex is transmission of characters. So in Teletex, you're really transmitting a document or pages of text. And in theory, the receiver, given a sufficiently sophisticated receiver, could even edit the text again. So you really receive it as characters of text and not as pixels of some low resolution black and white image. I always assumed until recently that given that Teletex is a logical step somewhere in between Telex and Telefax, that Teletex would be older than Telefax, but in fact they are developed sort of in parallel to each other, interestingly. So it's not that Teletex is clearly older. We will look at the history in a separate slide. But if you compare it with Telefax again, I think the key advantage that was also advertised at the time for Teletex is that you only need 10 seconds to transmit one page of text, lossless with error correction and so on. Whereas with Telefax back in 1981, I think only G1 and G2 fax existed, which meant 6 minutes or 3 minutes of transmission time for one page of text, with errors and lossy and very grainy representation at the other end. So that's a key difference, of course, and it's also one of the things that always was advertised by the proponents of Teletex. I think also we have to look a bit at the industry politics angle. I didn't really find any sources on this, so this is my own theory a bit, that the German industry was relatively strong in the office machine business of the 1960s and 1970s, meaning typewriters of all in all forms and incarnations. And I think this is a bit the idea or the approach of the German office machine manufacturers together with the German postal ministry to find new markets or a future generation of product for typewriters. Whereas I think the fax machines and the home computers, microcomputers, PCs, and so on, were coming from a completely different industry, of course. So the Teletex service was operational in Germany from 1981 to 1996. It was also operational in various other countries. We will look at that. The specification was done by CCITT, which is now called ITUT. And the spec numbers are given there. The F200 is the general overview. The T60, I forgot. The T61 is the character set. T62 is the session and document layer, and T70 is the transport layer. Don't recall what T60 was off my head. So let's look a bit at the timeline. So in 1976, there was a KTK commission. I forgot what it's like, a committee for the future of communication technology or something like that. That commission was a government committee that should have predicted sort of how communication evolves over the next decade or so and what to do. And they recommend to introduce something called Bürofernschreiben, which is the original name for what was later renamed to Teletex. There was also another term used in the early days, which is, I'm trying to remember the exact German word, Textfernverarbeitung, so like remote text processing. And in the same year, after this commission concludes, Deutsche Bundespost, being the German incumbent postal, the postal ministry at the time, suggests or proposes Teletex as a service inside the CCITT, the International Club of the Phone Operators or Telecommunication Operators of the world. According to some sources, it didn't resonate all that well internationally, but it was published in 1980 as an initial release of the CCITT recommendations. I'm not sure if this is a typo, actually. I found that one source that claims there was an S60, S61, and so on, whereas the modern ones are T series specifications. Not sure if that's correct or that was a typo in one paper that I read. So take that with a grain of salt. In March 1981, Teletex trials started in Germany using pre-standard Teletex equipment. So they were using a national draft, which got modified in the CCITT process. And then in November 81, they had to switch from they decided to switch from the national pre-standard Teletex to the CCITT standard. So it's a bit like a German national ISDN and Euro ISDN some decade later. Or not even a decade later, I think it was 88 to 90 or so, which meant that all the equipment had to be updated. And of course, at that time, it meant swapping of EPROMs in all the end user devices. I imagine that to be fun. Well, then more and more countries were interconnected to the German network. I didn't really find a lot. I also didn't have time to research a lot when Teletex networks were deployed in other countries. But the years given here is the time at which German documents state that interfacing to those other national Teletex networks was established. So we have Austria, then followed by Canada, USA, Sweden, Finland. So we see a strong Nordic country presence. Then 88, we have Denmark, Norway, South Africa, interestingly, Italy, Luxembourg, France, Netherlands, Switzerland, Belgium, Turkey, and UK. It's quite interesting to see Turkey, for example, in there, where all the other countries are at that time already highly developed countries, industrialized countries. I'm not sure what the story about Turkey in that context was and why they deployed such a network. Then we see already in 88, they see that somehow ISDN is at the horizon, and there are lots of people who say, oh, we won't buy Teletex because we wait for ISDN. And in order to combat that, they pass some, whatever the acronym expands to, this NVTKO, basically some change of a what is it? It's not a law, but a directive, I think, And to increase the attractiveness, they reduce the monthly fees, and they have some kind of trial subscriptions and all kinds of marketing mechanisms to try to get more subscribers. In 89, then they start interworking towards packet-switched data networks, and in 1996, finally, it got shut down because the excuse me, the circuit-switched packet data network that was used as transport mechanism in the German Teletex service was discontinued. You could still operate Teletex devices using an adapter over ISDN, and we will see that at the end of the presentation. Okay, something didn't work out. Okay, slide is just loading very long. Yeah, so if we look at the subscriber development, that was the prediction when they started the service. So we see basically 1980, then 81 some subscribers, 82, and so on, and they predict a very steep slope, and they predict that by 1990 they will already have 90,000 subscribers, and then 130,000 subscribers by 92. At the same time, they predict the Telex subscriber number will basically flat out. This is due to the fact that Teletex is deployed as a service that's backward compatible, so you can interoperate with traditional Telex machines and Teletex in both directions. We'll also talk about that later. So basically, the idea was that once Teletex is around, people will buy the new equipment, and they can still interface the old Telex equipment, but people won't buy new Telex machines anymore a lot. And the combined graph is here. So, well, things worked out a little bit different. So these are some specific figures I could find in reports and papers from Deutsche Telekom. So we see the high number of subscribers. The top is reached in 1988 with 19,000 subscribers, very far from the kind of quantities they predicted, and less than that in the rest of the world. So we have 19,000 in Germany and 12,900 in the rest of the world, which is still a significant number. So it's not just a German-only service, but if you divide those 12,900 by all these countries that I listed, it's not a lot of subscribers in each country. And then by 93, they already had dwindled quite a bit to 6,600 subscribers, though the last figure needs to be taken with some care, because basically, I think from 88 onwards, or when was it? From 89, or where was it? I don't have it here. Well, there was at some point, basically between 1988 and 1993, they introduced an ISDN Teletex interworking device. And that meant you didn't need a dedicated Teletex subscriber circuit anymore and a subscription anymore. You could just have your Teletex device attached via this adapter to the ISDN interface. So you don't really know how many people were using Teletex devices behind their ISDN lines by that point. So the 6,600 is just the number of dedicated subscriber lines, the subscriptions with dedicated circuits for Teletex. So this is another graph about the reality, comparing it with other services. So we have a graph here. That's the Telex in Germany, this graph here. So we see, and this is in thousands. So we had about 1.7 million Telex devices in Germany around 1985. In the rest of the world, we have the figure here. I think that's then the right. Is it the other way around? Probably this is the world. Yeah, I don't know whether the left one is Germany and the right one is the rest of the world, or the other way around. I don't know, to be honest. In any case, we can see that the Telex peak is around 87 or so, a little bit sooner in Germany than here. Then we see the Teletex. That's the one we're talking about here today. The worldwide subscriptions here also peaking interestingly at the same time that Telex peaks, and then deteriorating from that point on. And in Germany, it is this lower graph at the bottom here. While at the same time, the Telefax subscriptions, of course, explode. So we see the kind of slope here. Here is skyrocketing is the number of Telefax subscribers. So basically, Telefax obsoleted Teletex, and nobody really needed the specific how can I say specific advantages of Teletex in the end. So what kind of user equipment did the service have? The usual basic device was a electronic daisy wheel typewriter that was extended by a communications interface. So around the time Teletex was introduced, there already were not just electric but also electronic typewriters, typically with daisy wheel, that had a memory for typically a few lines of text. So you and maybe like a 1, 2, maybe 4 line display. So you could edit a given line before actually printing it on the paper. So you didn't have, so it was easy to fix spelling mistakes and things like that. And this type of device, or this class of device, was extended by a communications interface, so that you could basically transmit these texts remotely. Of course, the memory also had to be large enough to cover at least one page of text. I think the recommendation was to have 32 kilobytes, but it's just a recommendation, not a requirement by Deutsche Bundespost. Yeah, we had this kind of memory sizes for storage. It was also, that was a requirement, not just a recommendation, to have a battery buffer for the memory, so that if your Teletext device is receiving a document over the communication network, it stores it in its RAM, and that RAM must be battery buffered, so that even when there's a power outage between receiving the text and printing it, that it is not lost at that point. At the higher end, there were purpose-built text processing computers. They were not called computers, they were text processing systems that had a CRT screen and a printer of some sort. The most popular one in Germany is the Siemens T4200, but there also was, for example, a Commodore system, and we will see some other pictures. I was quite surprised to find some literature that claims there were more than 200 different Teletex device models from 60 manufacturers available at that time. So that's not the total number of devices over the entire duration of the service, but just in the year 1987, you could find that many different devices. I find that extremely surprising given the small number of subscribers, right? If you have 200 different models and you only have, what, 20,000 subscribers, that meant, well, on average, every one of these only produced 100 units. Of course, it's not equally distributed, but it's quite odd, I think. So this is the unit that I have here. It's called an Olympia disk with IKBS. So the Olympia disk, I think, is the normal electronic typewriter, and the IKBS is the internal communication module that was added to it. You can see it's actually an A3 paper size. So this is an A4 page here in the paper slot. So you could do A4 in landscape mode or A3 sized letters with this device. There's a 2-line VFD display here that you can see. Well, you cannot see it, but it's here in this area in the middle of the device, and you have a normal typewriter keyboard with some extra keys and function keys that relate to the Teletex functionality. This device is, well, I don't know about the communication part, but the typewriter part is fully functional, both the electronics and the mechanics. The only part that's broken on this is the transport of the ribbon, the ink ribbon. So that is not transported, and I would need to 3D print some part if that was something I was interested in fixing. But apart from that, it looks like everything is functional. I also dumped all the EPROMs, all the software, everything. There's a page on the Osmocom wiki with a tear-down pictures of the individual boards and so on, if you want to see more about this unit. That's the only Teletex device I own. I have a couple of other pictures from contemporary material. So this is from DTV, a German manufacturer, their Teletex typewriter. This is a Telenorma incarnation. You often see this setup with the actual typewriter and then 1 or 2 boxes. One of the boxes often is a floppy drive with 1 or 2 floppies of various different, even sometimes exotic formats. So this the unit that I have, for example, has a 2-inch Olympia specific floppy format that's completely exotic and not used by anyone else but Olympia. Not even the same than other exotic 2-inch floppy drives used by other manufacturers. And the other box then typically is the communication interface. So few manufacturers put the communication interface inside the typewriter. So you basically have the 2 boxes, the add-on devices to your typewriter, the floppy drive, and the communication. It could be vice versa. I don't know which one is which in this picture. It's not very clear. This is a very common model that was sold significantly in Germany, the Welte ET351, 351 TTX. I'm not sure if there was a version without TTX. So here you can also see the 1 or 2 floppy drives attached to it on the right-hand side. And the floppies were used then to store the documents that you received or transmitted. So you didn't. You could store them digitally for later editing or these kind of things. There was also functionality which was for like a document polling. I think in Telefax this was also used at times, fax polling. So you could call some fax machine and then the remote end would send you like an order form or a product list or a parts catalog or something like this. And the same principle exists also in Teletex. So you could imagine somebody calling in and then downloading, in quotes, a text document that's stored on a disk here. Even Ericsson produced Teletex equipment. Of course, the Nordic countries deploying Teletex networks, they didn't want to buy everything from Germany and Italy. I don't know how many of those were sold or how popular these were, but that's the only picture I could find from a paper. That's a more modern Olympia called the Master Text system. You can see it's always the same. You have your typewriter, you have some additional function keys, you have a 1 or 2 line display here, and that's it. And then there were the more high-end systems, as I mentioned, with a CRT screen that basically looked like a PC but were not a PC. You had some kind of computing device, a CRT screen, a keyboard. I'm not sure what this special function key block or whatever it is was used for here in this context. A floppy drive, of course, and this is actually an incomplete picture, at least from the German point of view, because the German requirement said it must have a printer. So a pure software PC implementation without a printer would not have been able to get approval from the Deutsche Bundespost, because a printer was mandatory equipment, at least one printer. I mean, you could have multiple, but at least one printer is a mandatory part of a Teletex system. This is a Triumph Adler system. Again, you have a CRT screen, some kind of computing device, a keyboard, floppy drives. Again, no printer visible on this picture. I mean, I'm sure it was just sitting next to it. And this is another Triumph Adler device. I mean, that really looks like a PC from the outside, but Triumph Adler did lots of strange computers back in the day. We used to have some of these at one of the schools I was at. They had nothing. They were not compatible to anything but to themselves. So how does it look like in the protocol, in the communication protocol? The specs say, well, level 1 to level 3, it's of course modeled after ISO-OSI model, and layers 1 to layer 3 can be either circuit switched packet data network, packet switched circuit switched public data network, packet switched public data network, or public switched telephony network, later also added ISDN. So that means that the actual Teletex specs for L4 to L6 are completely independent of the transport, well, not the transport, the bearer underneath. And the original deployment in Germany was using a CSPDN, the circuit switch packet data network, using the Datex L network. I gave a retronet call about the .xl network if you want to learn more details about it. But it's basically a completely separate network from the telephony network. You get a separate line into your house office, and it runs different. It's not a telephony circuit. You don't have dialing like a telephony network. It has digital signaling on the subscriber line, and you have a bit synchronous 2400 bit per second interface. And the subscriber interface was not the phone jack in where the phone line or the teletext line arrives, but the X21 synchronous interface. So basically the the operator of the teletext network provided you with a data communications equipment, and that data communications equipment offered an X21, a circuit switched X21 interface, and that was the interface to the network. And it's the only interface that's specified for Teletext. And in other countries, I think particularly in the US, they used packet switched network as the bearer because they didn't even bother to deploy a circuit switched data network. And it's also possible to use synchronous 2400 bps modems. I don't think I read that this was used anywhere, at least the specs would permit it. And as I said later, when ISDN came out, of course, you could also transmit those 2400 bit synchronously using rate adaptation over ISDN. Now, the actual three layers of the protocol stack is the transport layer, the session layer, and the document layer. So it's already surprisingly complex, given that you would implement this in a typewriter, basically, and using, I don't know, 8051 type microcontrollers or something like that. So let's look at these protocol layers individually a bit. And before we go into that, some more basics about the idea of this protocol system in Teletext. So we have the concept of pages, and a page is basically formatted text. You could think of, I don't know, an ASCII text file. Of course, it's not ASCII encoded, but some kind of monospaced text file with some formatting and special character capabilities. A document is a collection of pages, and you transmit documents over the Teletext service. And sessions then are used to transfer documents. So you basically establish a transport layer, then you establish a session, and within the session you transmit documents, and each document consists out of pages of formatted text. The sessions are unidirectional, so within one session you can only transmit documents in one direction. If you want to transmit a document in the other direction, you need to establish a new session in the other direction. So it's once the session is established, it's unidirectional. And there's terminology, session master and session slave on the session layer, and then also on the document layer, we have a document master and a document slave. So at the session layer, the calling party is always the session master and the called party is the session slave. And there's no way to switch that. You have to call the other way around if you want to have sessions in the other direction. In the document layer, you have the ability to swap roles. Again, the calling party is the document master initially, but there's a command that can be used to swap the roles to transfer documents in the other direction. So the transport layer is very simplistic, the T70 layer. It only has 4 different primitives, a connect to establish a connection, data to transmit higher layer protocol data. It includes a segmentation mechanism to segment larger messages into smaller ones, a disk for disconnect, and some exception message for reporting of errors. So it's super simplistic, not all that much to do there. And of course, there's HDLC. I didn't mention that, but since it's a synchronous protocol, of course, there's HDLC involved. So in order to actually have message boundaries transmitted over the bit synchronous protocol and have some CXC, you have HDLC basically as part of the lower layer bearers that carry this layer 4 T70 protocol. Within Sorry, yeah, that's the primitives, and the messages. We have only 5. So transport connection request, accept, and clear. Pretty obvious what they do. There is a reject message that can reject any of these blocks. That's why they're all called blocks, the first 3. And then we have a transport data block. And the TDT message is used to encapsulate a higher layer messages, and that then brings us to the next layer, the session layer of T62. We have lots of more messages, so the layer, the session layer and the document layer are much more complex than the transport layer. So these are just the commands on the session layer. I'm not going to read through these, just to give you an idea. Also, the naming is very weird. If you are younger than, or you're more familiar with younger communication systems, where you have like request and response and acknowledgement, and no, here they have like positive and negative instead of ak and nak, and so no request but command. So it's the terminology is a bit odd if you come from modern technology. The document layer has even more message types, and each of those messages then can have lots of information elements. So the encoding decoding is actually relatively complex, or surprisingly complex. I started an encoder decoder for this, and it's not simple. Lots of different information elements and fields. So let's look at how this looks like in a diagram. This is a ladder diagram from some secondary literature textbook about Teletex. So we established the circuit switched packet data network call, and then we have at the session layer and the transport layer, and then in the transport layer we have these 2 messages, CSS and RSSP, that establish a session on the session layer. I again put the expanded acronyms over here. And then after the session layer is established, we can transmit documents. I think you can transmit even multiple documents, and each document then has a couple of messages. Of course, the CDE, the CDUI, the command document user information, that's actually the content of your text document, can happen multiple times to transmit all the data. This is the only successful case. There can of course be errors and retransmissions and things like that. And in the end, once all the documents are transmitted, the session layer is torn down by command session end and response session end positive messages here, and then the transport and bearer channels are torn down again. In terms of equipment, there's also test equipment. The only test equipment that I know of is the Wandel and Goltermann DTX1. It can simulate the circuit switched packet data network switch. So you basically, if you have 2 Teletex devices, I unfortunately only have 1, but if I had 2 of them and the DTX1, I could interconnect them and basically not need a public network to send text from left to right. It can also passively trace and decode Teletext protocol between the network and the device, and the protocol traces are printed on a parallel printer. In order to capture that parallel printer, I first built a parallel printer emulator that I can attach to the parallel port, so I can capture this digitally rather than have it printed on some thermal printer. This is how the DTX1 looks like. I have been temporarily provided one, basically a guy in the Telex forum. He has, I think, 3 of those testers alone and lots of Teletex machines. And he borrowed me one of these for my experiments. This device looks brand factory new. Like none of the buttons shows any kind of usage that the buttons have been pressed or are worn out. There's no scratches, there's nothing. So I'm quite sure this device was basically surplus at the time when nobody was interested in Teletext anymore. And it has all the accessories, all the manuals, all the even the schematics, everything. It was in the suitcase, so it really looked like it was built yesterday. I also did a teardown of this. I don't think I've uploaded all the pictures yet, but also at least the EEPROM dumps and so on, I've already uploaded to the Osmocom wiki. If you're interested in it, also the manuals and schematics and everything has been scanned. I think it's also here. Actually, you can see a picture of the circuit board. I think it's the open page here on this picture. So yeah, all of this has been scanned and is available, I think, on the Osmocom wiki page. In case anything is missing, let me know. There's even some special, if you see these circuit boards adapters here, those are for the Siemens T4200, one of these CRT screen text processing machines, which had a plug-in module for the data communications equipment. So you would plug in the DCE. So if you there's no X25 on a DB15 or some other connector. It's basically only a backplane connector type. So with these adapters, you can plug into the backplane of the T4200 and basically emulate the DCE towards it. So they went that far to actually include adapters for one specific Teletex machine. Yeah, so then one topic is Teletex Telex interworking, which was a network-based device called TTU, Teletex Umsetzer at Deutsche Bundespost, which permits interworking between legacy Telex devices and Teletex. So legacy Telex, of course, is the whatever, what was this, 50 bit per second asynchronous service with current loop interface and God knows what. And Teletex being this modern synchronous 2400 BPS system, so there had to be a lot of adaptation in between. And you had some special prefix to dial 18 or 17 as a prefix to go from one end to the other. If you were sending a message from Teletex, from the more capable Teletex to the old Telex, you had to make sure not to include any characters that are not cannot be translated to the 5-bit character set, and also only limited line length. I think what was it, 69 characters or something like that. So there were some constraints you had to observe when you use this in that direction. From Teletex to from Telex to Teletex, of course, it's easier because you can always convert from the more simple representation to the more comprehensive one without any problems. Each of those TTU devices had 16 channels for either direction. So if you look at this, it looks a bit like it was used with PCM technology. So you had, I don't know, 32 channels for both directions. And what I found most interestingly, that there was a manual human operator-based overflow workstation. So in case a message doesn't get delivered after 5 unsuccessful delivery attempts, then it would end up on this desk of the overflow workstation, and then the human operator could retry at a later point in time. I didn't yet see any documentation how this looked like. I'm not sure if there was like a punch card or a floppy disk for the overflow, or whether that was stored on some kind of hard disk or core memory, or God knows, I don't know how this worked. I would guess maybe it was a punch card or a punch stripe or something like that. I don't know. Just sounds interesting that there was a human operator involved in handling overflows. Yeah, this is just some ladder diagrams on these two translations from Telex to Teletex and vice versa. What's interesting, to me at least, is that there's some kind of special mnemonics that were sent to the Telex. So for example, you see at this point there is MOM. MOM is for moment or moment. So basically, please wait. So at a certain point in time, the TTU device would basically write a MOM out of the typewriter on the teletype on the Telex side. So that subscriber would wait for some transaction to complete at the other side. Also, previously there would be a TTXD. So these are basically small mnemonics that would print out on your Telex device that are generated by this translation device in the middle. Yeah, I guess none of these survived anywhere. Later, then there was also interworking to other services. So as I mentioned, to ISDN attached teletext devices, so you could have one subscriber in the actual CSPDN and the other one attached to the ISDN, and they could talk to each other. Also, then at the end, DATEX-P, the packet switched public data network, you could attach teletext to that and interface to a native teletext device. There was also a BTU, BTX teletext Umsetzer. So the video text system called Bildschirmtext in Germany, also it was possible from there to write text messages to teletext subscribers. And there was a special deep converter for that. I think it only worked in the BTX to teletext direction and not the other way around. And also there was an integration with CityRoof, which is a pager service. So you could page pagers using your teletext machine from the teletext network. And I think there are even some more exotic interconnects. So there are some nice diagrams how the ISDN Teletext Device Interfaces using the Verbindungsübergang 1-32 with the circuit switch public data network teletext device. So the native teletext network and the ISDN adapted teletext device, and some translation in the network of Deutsche Bundespost at the time. This is an overview of the interfaces with other networks. So we had the Teletext network in IDN, which is the another word for the the platform that was carrying all these different services. And you can see those interfaces to DATEX-P, DATEX-L, to Teletext devices natively, but also Teletext devices attached to ISDN. And then the interface to the Telex network, to Telex and CityRoof, and even Telegram. Yeah, you could actually send a telegram from your Teletext device at some point in time. Yeah, so what is my goal with all of this research? Understand the system better, of course. I think I have a good idea now, but of course I don't yet know in detail the formatting of each and every message that gets transmitted. What I want to do is I want to talk from my own software on some Linux system to my Teletext typewriter, the Olympia disk, and want to be able to take protocol traces and publish them just in case anyone else ever has an interest in this. So as long as I have at least one working Teletext device and we can generate real world protocol traces, yeah, and share those results. So the more detailed plan for open source implementation, the first step is to create an X21 adapter, because the interface of this teletext device, all of the teletext devices, I think, is X21. And that's a work in progress. So I started with an RP2040. That's the Raspberry Pico microcontroller, which has these nice synchronous PO units. Use that for synchronous X21, and in general, there's no rocket science involved there. There's RS422 transceivers for the actual line interfacing. The most difficult question is how to represent this over the USB protocol, because the CDC ACM and other USB serial protocols only think of well, serial characters, let's say, and think of asynchronous interfaces. And most critically, the question is where and how to implement the actual state machines and the protocol for the dialing and the signaling of a real circuit switched X21 interface. Since here in Teletext we really use the excuse me, this mechanism, which is not used anywhere else. When wherever X21 is used, normally you don't use this, and Teletext is sort of the only service I think that uses these obscure parts of X21. And yeah, how to do that? I mean, it would make sense to implement that all in the firmware, but then yeah, how to expose an interface to that? That's sort of where I'm not very clear yet. There's like an infinite number of options, and haven't really found the magic solution of what would make most sense from my point of view. Yeah, then once this hardware interface and the call control signaling exists, basically the network switch, the CSPDN switch needs to be emulated. So basically it needs to accept incoming calls and generate outgoing calls and signal the call party, calling party, and all that kind of stuff. And once that exists, I can actually establish the bearer for the higher layer protocols, and I can start to talk T70 to the Teletex device, and later then the T62 protocol. Yeah, and in the end, I want to have something where sort of the formatted text page gets rendered as an ASCII text file, and or vice versa. I can send ASCII text files to the other side. So the job is done once I can transmit the GNU GPL over the over the system, and it gets printed out from the Teletex device or something like that. Yeah, it's a very low priority project, so I don't expect big progress soon. But yeah, given that I have these devices, the DTX1 and the Teletex device, I think I want to go to at least the point where the CSPDN is emulated. That I want to get in a foreseeable future. So let's say in the next couple of months. The higher layer protocols, I'm not sure when I will find the time and energy to do that, but I will do it at some point for sure. Yeah, further reading, well, there's the retronetcall. It's not really reading. Well, the slide, you can read the slides or watch the video. There's the retronetcall on X21 and the one on the Datex L CSPDN, and there's a couple of links here for the Teletex wiki page in the Osmocom retro networking wiki, and the DTX1 and the IKBS one. And the Teletex one has a list of literature references, and yeah, let me know if you need copies of any of the books or papers. Yeah. And with that, we are at the end. Does anyone have questions on the record? Then let me ask, okay, somebody's typing, but meanwhile, let me ask, does anyone on the call own any Teletex equipment? I would have been a bit surprised, but then there are some new names in the list of participants or in the on the call, so there might have been somebody showing up. But yeah, I mean, there is a couple of people on the Telex forum. There is a German Telex forum, and there's a number of people who have equipment. I would say at least 4 or 5 I've seen in reports there. So would be interesting to get those sort of connected with the software somehow. There's also at least 1 or 2, I think, on the retro computing forum of VZEKC. Yeah. So there are a couple of people out there. So I think once I have something that does something useful, there will be people who want to reproduce it. Yeah.